Well, we're going to go ahead and find the exact answer for the area underneath our curve of 100 minus 3x squared. We're going to look for our area between x being 1 and 5 on that curve. Now, it's estimated with these rectangles over here, but we want to find the exact value. So here's our formula that we want to use. Yes, it looks a little scary, and in this case I actually do have the limit in front that I'm supposed to. We're going to have to rewrite that each and every time. We now have our formula for delta x, which once again is b minus a, the end minus the beginning, all over n. So we get delta x to be this. We then also have our x sub I. X sub I is your beginning, which is starting at 1, plus your delta x, which we had right here, times I. So now we have our x sub I. So we want to go and rewrite just the f of x sub I, and we're going to get this. Because it says take your function is 100 minus 3, and then you got to have your input. Your input's x sub I, according to this, and then it's being squared. So now we're going to go ahead and we're going to replace our delta x with our 4 over x. We have 100 minus 3. Now we got to substitute in x sub I. X sub I is the 1 plus 4i over n. So our x sub I is what we have right here, and that's what we plugged in. Your delta x is what we had here, and that's what we plugged in. All we have to do now is do a little bit of simplification. So we're going to have to FOIL out our parentheses here, and we would get this. So that matches up with this here. Now we got to go ahead and distribute that negative 3 through. And then we want to combine our like terms. The only like terms we have are our 100 minus our 3. Now we're going to do a little bit more work. And all we're going to do is we're going to distribute through our 4 over n. And at the same time we distribute through 4 over n, we're also going to distribute through a summation. And so then we end up getting this. Well, now we want to use the properties of our summation. We want to take our constants and pull them out front. We have no i's here after the first one, so we're going to have to pull that 388 over n out in front, leaving us with a 1 afterwards when we pull that out. Here we have an I, so everything that doesn't have an I we're going to pull in front because that's your constant, leaving you with an I to the first. Here we have an I squared, so anything that's not an I squared we'll pull out in front. So now we have the sum of I, but we have a formula for the sum of I, or sum of 1, sorry about that, sum of 1, that formula. So we're going to want to go ahead and plug that in. So we plug that in, and that's just your n. We also happen to have the formula for the sum of I. Formula for sum of I is right here, and we're going to want to go ahead and plug that in. So we'll take that and plug it in, and so what we have here in the parentheses is your sum of I. At the very end we have a sum of an I squared. We have our sum of I squared formula right here. We're going to want to go ahead and plug that in. And that's what we have here. Now Let's just go ahead and distribute through our negative 96 n squared, our parentheses. Distribute through our negative 192 over n cubed into a parentheses. Combine some like terms and we end up with this. Now we can easily take our limit. Sum as n goes to infinity has no effect on your 388. Has no effect on your minus 48. Does have an effect on your 48 over n. As n gets really big, the fraction goes to 0. Minus n has no effect on your 64. This fraction has an n in the bottom, so it's going to 0. This fraction has an n in the bottom, and so as n gets really big, it goes to 0. So now we go ahead and do a little bit of arithmetic. You can do that in your head or your calculator. And you get an area, an exact area of 276.